Hello guys, so we are going to talk about smoking. So the World Health Organization currently estimates that each year smoking accounts for about up to 6 million deaths worldwide and causes about $500 billion in economic damage annually. Nowadays, many people like smoking, and apparently smoking is harmful. It is difficult to quit smoking addiction for many smokers, but recently there is a brand new way to give up the smoking habit. Today, what I want to talk about is how nicotine-eating bacteria could help smokers kick the habit. As we know, quitting is difficult. According to ACS Journal of the American Chemical Society, scientists are successful testing on a bacterial enzyme that breaks down nicotine and could potentially do its effects in humans. They used an enzyme called Nic-A2 that comes from Pseudomonas perdita, which is a kind of bacteria already known to degrade tobacco waste. How it works. In lab tests, the researchers added nicotine in the same amount as a cigarette to the serum of mice. When they added Nic-A2 to the serum of mice, it broke down all the nicotine in the blood samples in 30 minutes, and no observation side effects on the mice which are given the enzyme. Researchers found that the enzyme was not only effective, but also stable, and the decomposition products were also non-toxic and harmless. The enzyme remained stable at 37 degrees Celsius and at 3 degrees Celsius as well. It is also stable in serum, but researchers still need to do a series of studies to make sure the enzyme is suitable for the human body. If the enzyme is derived from the bacterium, researchers need to do a series of work to protect it from the body's immune system. Nicotine-degrading enzymes can rapidly reduce the concentration of nicotine in the blood and deliver nicotine to the brain. It has been known that some bacteria that live near tobacco plants for more than 60 years can degrade nicotine. For example, Nic-A2, which is one such enzyme, isolated from Pseudomonas perdita, can use nicotine as its sole source of carbon and nitrogen. Nic-A2 degrades nicotine to methylsarcosine by flavin-dependent catalytic oxidation, and methylsarcosine is further hydrolyzed to pseudonicotine. This pathway is distinct from that of nicotine metabolism in humans, where the conversion of nicotine to cotinine via cytochrome P450 enzymes accounts for 80 to 90% of endogenous nicotine metabolism. The remainder is metabolized via minor pathways including conversion through 2-hydroxynicotinic to pseudonicotine. Nic-A2 mimics this minor pathway. Nic-A2 has high catalytic activity, and it rapidly degrades nicotine in vitro at nicotine concentrations representative of serum concentrations in heavy smokers. Thus, smokers or users of tobacco products are already chronically exposed to pseudonicotine and its metabolic intermediates. An initial study of pseudonicotine safety in rats showed no adverse effects after 5 weeks of administration. Among nicotines metabolized in humans, only nornicotine is known to share its addictive properties. Therefore, degradation of nicotine to pseudonicotine via Nic-A2 is an attractive strategy for enhancing nicotine degradation and thereby reducing its effects. Question: how do microorganisms are capable of breaking down tobacco alkaloids by different biochemical processes? Various microorganisms are capable of breaking down tobacco alkaloids by different biochemical processes and possess characteristic enzymatic systems for the catabolism of nicotine. Bacteria of the genus Pseudomonas and the fungus Cuneihamula acuminata degrades nicotine via N-methylmyosamine and pseudo-oxynicotine, which is linked to the opening of the pyridine ring, whereas Atrobacter oxidans hydroxylate the pyridine ring in the 6th position. 6-hydroxynicotine is produced as a primary product. Tobacco plants and some fungi degrade nicotine via demethylation to nornicotine. To conclude, nicotine-eating bacteria is an efficient way to help people quit smoking. An enzyme called Nic-A2, isolated from Pseudomonas perdita, can degrade the concentration of nicotine in blood so that it can empower people to give up smoking. In addition, there are some microorganisms like bacteria of the genus Pseudomonas and the fungus Cuneihamina acuminata can also degrade nicotine. It means there are more opportunities to help people quit smoking in the future. Therefore, I believe one day we can overcome the urge to smoke and live a healthier life.